Welcome, everybody, and thank you for joining. We have our session on AuraDB. Today, Michael is stuck in the middle of something somewhere. I'm hoping he'll join in a second. I think he needs to find the proper room to join us in a very moment. But yeah, this is the series about AuraDB, where we look into our graph database as a service offering to help you figure out if that is something you're interested in, if that is something you want to try yourself, and we show features and capabilities that you might not be aware of, that you are might have overlooked or might have missed because they are added constantly, and the platform changes obviously as we speak. So it is an evolving source for you, or an evolving platform to use. So give it a try. And today, I think Michael told me, but you never know. But the plan was to do some big quick query import and then some graph data science on top of that. So we'll see how it goes. But yeah, let's give him a couple of more minutes so he can join. In the meantime, what I usually do at the end, but might as well do it in the beginning today, is what is happening in the future. So also spend a little bit more time on this. So we have regular streams here on YouTube, as well as on LinkedIn, Twitch, and on Facebook. So if you are on any of these channels, subscribe to our channel, give us a like, let us know what you like, let us know what you don't like, let us know what you would like to see in the future. So we were always trying to add things that are interesting to everybody. So we hope we can cater something that is of your interest. The next session that comes up on the 5th of June, so next Thursday, will be a overview of the AI Engineers World's Fair GraphRag track. So we have the pleasure of hosting a full track at the AI Engineers World's Fair in San Francisco next week. It's running all week in San Francisco. And my colleague Andreas is track host for the GraphRag track and gives us an overview of what to expect during the day, what he also has already seen, what others are doing in the space, and he gives us a little insight into the space around GraphRag. So I think that's super interesting and should be very, very much up to date of what's currently happening around that space. So everybody talks about it, and we like to see more, and we to hear more. And then there's a question in chat from Veronique. Joins, can you tell us why this is called Season 2, Episode 3? What is the series this webinar part of? Is this the Neo4j Live or specific series on Aura? Yes. So exactly, Veronique. This is a specific Aura series, or Season 2 is because we did something like it similar a while ago, and we paused it, where Michael and I dove into specific smaller data sets, but on various topics, from biology to fraud to people to supply chain to fire outbreaks in California to some NASA data sets. And we showed the capabilities of even the Aura free version that gives you 400,000 nodes, 200,000 relationships. So already a pretty good set you can play around with. And we thought, okay, we pick a data set, we add that data set, import it into an Aura free instance, play around with it a little bit, have some fun, run a couple of queries and see where it goes. And that was a while ago. You can still watch all those episodes if you're interested in previous editions, where maybe some specific data sets are interesting to you. Look it up and have a look at that. And then earlier this year, Michael and I, we said, hey, we had now so many new features added to AuraDB, so many new, the interface has changed with the new workspace experience. We had lots of features, lots of things, and we thought, okay, let's keep, let's do it again. Let's pick it up again and do some have some fun, but this time not as much focused on in specific data sets and finding a data sets every week. Now we take the series a little bit more relaxed. We have spread it out a little bit more, but then we focus on certain features, some capability to look at the possibilities that there are and the new features that you can explore. I have shared the link in the YouTube chat. Is also part of the video description. So if you click on that, then you find all the previous episodes from before. And hello. Yeah, I just said you are running around finding a space between the conference or the event you're at, and find some
exactly.
quiet
And I also
somewhere.
dressed up as my dad as well. So
yeah, it's good.
oh man, it's a GovTech. It was a GovTech event where I presented about Panama Papers and investigative journalism.
Oh, cool. Yeah, well, that's
financial
exciting.
crime and so on. It was kind of funny. Last week I was in Singapore, which was actually pretty cool, by the way. I've never been there before. And it was really cool to have the GovTech people in Singapore present actually about GraphRag and Neo4j that they've been working on for a year now. And here now I'm in Germany and in GovTech. Actually, the space is pretty cool. They have like in Berlin here, like a GovTech space where they do like industry and government collaborations. So there, for instance, around the corner there's KPMG space, and then there's something from Deloitte around the corner as well. And like
all the info.
I think Neo4j we also have a space somewhere here, but then like there are also the government agencies here. So that's kind of cool. And so I just snuck out of the event to not leave you all hanging. And I got like a cubicle. And,
okay, cool. Yeah, I wonder how long it's going to take until you hear a GraphRag story from a European government.
Let's see. Yeah. I mean, I had some really good discussions in the break on like they wanted to know how to use GenAI and where does it make sense and how do you do data extraction. And we had also discussion on, we shouldn't trust LLMs as such, but you can use them for their language skills basically and for extraction and summarization and answer generation, but the data needs to come from a trustworthy source as such. Yeah. So from that perspective, they kind of know the direction, but I think it's still quite a bit out. Especially, I mean, in government, there's also much more regulation and
and the data,
as such, right? So the data privacy, exactly, right? So it's much easier in a startup or as a hobbyist or working with some open source data to do it, right? But if you go into like something that has to do with government or citizens or so, it's of course you have to adhere to the
I think that's a big issue. As always, that's the first question that comes up. And what about data privacy? And what about security? And all this?
Which is correct.
Which is correct. I mean, you absolutely have to take care of this. You don't want. I mean, in the beginning, we this applies to every company. Not even if you're not a governmental organization where you have to make probably a little bit more extra sure, but still, I mean, you don't want your data to leak out, and nobody wants that. So it has to be safe.
Exactly. Yeah. Cool. So I have prepared something, and I hope all the demos will work.
Cool.
So let's see.
I gave a little teaser that I said you told me that you want to do something with BigQuery imports and then some GDS.
Yeah. Let's see.
On top of that, we'll see how it goes.
So exactly. So the topic of today's Discover AuraDB free. Can you see my screen, by the way, Alex? Can you?
Yeah.
Okay. Super.
It's always changing here, but here it is. Here we go.
So the idea is the following: as we have added more data import capabilities in Aura, so this is like an internal view, but you should be able to see at least MySQL, SQL Server, Oracle, and BigQuery. I think that's what's public already. So I thought we just used.
I think that was BigQuery was something that we added recently, didn't we? Or was
Snowflake and the other ones.
Snowflake,
Right. So I thought we show how to import from BigQuery, and then we can run some graph designs on top of the dataset. First as a GDS plugin, and then later we can try to get the also newly released, let's see, blog, the newly released Aura Graph Analytics.
That would be cool. Yeah.
Which is running as a separate serverless offering, basically. All right. So I can send you this, or perhaps you can Alex.
I'll put it in chat. Yeah.
Okay, let's see how far we get. And I told the team that we're doing this live, and so now they're no pressure. Let's see.
We're always
okay,
doing it live, so I mean
we're always
that's
doing it live, right? So it's not a big deal. So I created for our first run, I created just an AuraDB Pro instance here.
Mhm.
And if you look at configure, it has also Graph Analytics enabled. That's available from 4 gigabytes, which you can also run as a trial instance as well, right? So you can also kind of test this and use this for free as well.
Yeah, so that's important to say. So there is a free version or AuraDB free. You can spin up anytime and play around with it, but it is a bit limited in terms of storage and in terms of memory, particularly. And but the Pro edition has now a trial version as well, which you can try out and just give it a shot and see if that is something that works for you.
Exactly. And one thing that I wanted to mention at least is at least on GCP, and I think also on AWS, you can have now separate memory and storage. So this 4 gig instance can get up to 32 gigs of storage, which actually only adds like a few dollars per month.
Yeah, that's not too much. Yeah, I see.
So it's not too much, but it gives you much bigger store sizes. So if your hot data set in memory is not as big that you need the full, whatever, 8 or 16 or whatever gig, then this is quite nice for. In the past, we only had 1 to 2 memory and storage ratio, and now we have also 1 to 4 and 1 to 8 as well. So that's actually quite nice.
Yeah.
So I created this with Graph Analytics enabled, so we can run some GDS on top of it. Okay, and then I have this really super simple data set that I cloned from BigQuery example data set cycle hire. So there's a UK London cycle hire. No, I think there's this one. In the BigQuery marketplace, there's an London bicycle hires. I'm not sure whether this is Spanish, to be honest. This is very funny. My Spanish
maybe detects something or something,
but I don't know what it detects. Anyway, so this is like the London big bicycle hires dataset, and then you can clone it into your BigQuery account in Google Cloud, which I did here. And so basically for the demo, I have here the dataset with the full SQL basically. So we can basically look at we have cycle stations, which are basically the different stations for where you can rent a bike and bring it back, basically, right? So, and they have stuff like ID, latitude, longitude, bike count, dogs count, and so on, right? All with basically information here. And if you look at preview, you see basically some of these examples of, I don't know, 800 stations, right?
Yeah, across the city. Yeah.
Across the city, which makes sense, right? So, and you see like all the attributes here, right?
Yes.
And then you have the table for cycle hires, which is basically the rental, right? So when you rent a bike, then how long does it get rented? What's the start station? What's the end station? What's the start date, end date, and so on. So that's basically the trips and the journeys between stations, right?
That reminds me of the keynote we had at Nodes 2 years ago from Hannah Fry, where she said everybody rents a bicycle and goes down the hill.
Exactly. I think she
never goes back up the hill because it's so
she might even have used this data set actually. So let's have just a look at how much data is in here. I actually don't know. So it's a lot of data. So we're not importing all of it, otherwise we have to wait too long, right? So it's 83 million or 800 million. No, it's 800 million rentals, right? So I created just a view that has 10,000 such. My original view was just like select. I'm not sure. Do I see the select statement here? Yeah. So I just did a select with limit 10,000. But then the challenge is when you run this view twice, you will get a different 10,000. So it's not stable in a way. So my colleagues told me later on. So that means the first time you get 10,000, and the next time you get another 10,000. So they're not matched up. So when we load first time the source node and then the target node for this, basically, then it does not match up, right? So it's kind of two different data sets. And that's why they said I should actually sort this And so I changed this and changed it to unsorted by a rental ID.
I see.
So
Okay.
that's a good tip to know, because I didn't know that, and I wondered why I don't get relationships in my database. Right? Okay, and then basically the other thing that you have to do is create a service account to access this data. And then with the service account, you can create a data source in Aura or such. So we basically can go to import. I already did this a while ago. But what you would basically do, you would click on BigQuery, you put in your data source, your project ID, dataset ID, which you find for the dataset. And then for the service account, you can generate a JSON file with the security information. And that's what you pass in here, and then you basically get these things. But that's also in the documentation as well. Right. So I didn't want to do this all live on the screen with the security stuff. But you can imagine what goes in here, right? The project ID is just my Google project ID, dataset ID is the dataset ID that's actually here in the dataset itself. Right. So dataset is ID somewhere. This is the dataset ID here. And you have to remove the prefix, because it only takes the suffix here. Otherwise, you get a prefix twice, because this is the project ID already. And this is the actual.
I see. Okay, because it's underneath the project management. Okay, yeah, makes sense.
Exactly. And then the service account JSON is basically just the credentials for that service account as such. And when you have this, then you can basically go ahead and say, I want to create a new graph model from this data source. And it says connect and create model. So it connects to BigQuery and fetches the metadata. So fetches all the tables and their column descriptions and a few rows of data as well. So this takes a few seconds. Let's see. And then after it did this, you have here you go. You have like all the tables available, so we can remove the ones if you're not interested in. So this one and this one. Oh, sorry. We want to keep the stations, which is our cycle stations, right? That we just saw.
Yeah.
And we want to keep our sorted cycle 10K sorted, right?
Of course. Yeah.
And then we could now start doing the schema things. If you remember, in the past, we've always done this manually. We have for the, CSV, we dragged and dropped and drew a graph. You could generate it from the schema, but the BigQuery, like many cloud data warehouses, don't have foreign keys. So basically, we would just get two lonely nodes here. So we can also send this to our helpful AI companion and see what it comes up with. And what we do is basically send the headers and a few lines of data to the LLM.
Yeah, and you don't have to provide anything. Okay, that's pretty neat.
Right, and you don't have to provide anything. So you get basically this. You probably don't want to call this cycle hire 10K. So it's just cycle hire. And then we can also say this is kind of our end station. Right, so because that's the end station ID here.
I see. Okay, yeah.
And the other one we would call the start station. Right. So this is basically what we have here, right? So we could also say we only turn the rental into a relationship. That would also work, right? But let's keep it this way for the time being, right? So, and then basically that's it, right? So it did all the mapping for us and everything, right? So we don't have to do
that's pretty nice.
If you look at it, it even translated the spelling into our Cypher style guide, right? So bikes count is like lower case, and here it was like with underscores and so on, which actually quite nice as well.
Yeah, and it also realized all the different types of formats.
Data types as well, right?
Strings,
so
integers,
that's also good.
Boolean even. So that's very nice. Yeah.
So, and then we can basically just run import, right? So we basically say we need to connect it to our, that's the wrong database. Let me connect it to the other switch instance, and we want to connect it to Discover AuraDB free. Right. And then we just click on run import, and it will automatically connect to our Aura instance.
It's good that it asks you this again, so you can make sure that you don't
exactly. And then you see then you see basically the import job that it submitted, and it already started to run it as well. So if you go to our database here, It's currently still empty, right? But now we get like the first few
already coming in.
cycle stations in here, 10,000 nodes, 20,000 nodes. So it's actually also quite fast. So it's 100,000 nodes, I think, in total. Because we had 100,000 hires, right?
Yeah. It's probably creating a couple of relationships.
And now it
Here we go.
starts with the relationships. Already the first half is already there, and then now it does the second half of the relationship. So now after a few seconds, it imported. I think that should be it.
Yeah,
Job
it's
is
done.
completed, and it's looking all good, right? So that's basically what we get. So, and if you want to explore our data, then we say basically the blue ones are our stations, and the orange ones are our trips between the stations, right? So, and we could basically say, let's show, I don't know, 500 or something like that. So a little bit more, right? So you see also kind of trips between stations where like things follow each other, or different people use the different stations at different times, and then you can see these kind of flows between stations. Here, for instance, you have stations where multiple hires happen at this.
Oh wow! Yeah.
At this time, and so on, and so, and can go bigger, of course. So cool, and then we can do a bunch of other things as well with this data. So let's go perhaps to Explore. And Explore gives us an easy way to getting this data also visualized. So for instance, if I say I want to go from cycle station, from cycle station to cycle hire. Let's do this is our start station, then we go to cycle hire, and then we want to go to end station. So this is basically our pattern, right? So we basically start at the station, this is our hire, and then we do this. And so it fetches a lot of data here, and then we can even select everything and say expand all, and then hopefully you get a little bit more. So I hope it does not explode. I just wanted to show something basically. So we have now 4,000 nodes and 2,000 relationships or something, 3,000 relationships, right? And what we can do now here, we can do interactive graph algorithms. So let's remember we did an Aura instance that has GDS enabled. So we can basically just in Bloom here say, we want to do something like clustering. So these stations should cluster basically by when people are frequently traveling between these two stations, then it should basically form a cluster in a way, right?
Can you customize this in any way?
Yeah, you can select kind of what you want to include here, right? Which kind of relationships and so on. And so, for instance, if I had other nodes that I'm not interested in, then I could exclude them. So imagine there was also like an user account or something like that, right? So and I want to exclude a user account, then I would remove the user account as well. For some algorithms, you can also configure, I think, weight properties and so on, but fully in here, not right now. Right? And then we can apply this algorithm. So this runs on only the data that is in the visualization, not on the whole data.
I see.
And now we can basically see, that it basically colored our clusters, right? All the yellow stuff is in kind of one cluster, all the blue stuff is in another cluster, all the turquoise stuff is another one, the green ones are another cluster that forms a little small cluster here. That's basically things you also, as a human, you kind of see these clusters in a way, right? But the algorithm basically
it makes it much easier. I think they are, what are the green ones? Probably all the same.
Yeah, so all the yellow ones are connected to this one here, right? So all the green ones are connected to one of these cycle station nodes. Then you have like these pink ones here that are connected to something. Then there's like the dark purple ones and so on, right? So you have like all the different clusters as such. Light green one is here, right? And so that's kind of a visual graph algorithms. You can also do now another algorithm. So for instance, if you want to add another algorithm, like let's say we want to see degree centrality or something like that, which is a super simple one, which is basically just the how many relationships does a node have. And then we use size scaling. So we make these nodes bigger that have like more relationships. So you see the ones that are very connected, basically they get a higher degree of centrality as such. Right.
So do we think these are all mapped because they are in the same vicinity, or?
I mean, the degree centrality is basically just the relationship count, but it looks a little bit wrong, right? So because this looks like, let's see, this has a degree centrality score of 0. I think because it only counts the outgoing, so that's probably something that we can configure on the algorithm actually. Let's see. If you say undirected and rerun the algorithm again and apply size scaling. Now it looks better. See, it used the wrong direction basically, right? So it was looking just at the
Okay. Yeah.
outgoing or ingoing ones. Now you see basically the one with the lots of relationship is thicker than the other ones, right? And then the other ones are okay. So now it makes more sense from that perspective, right? So the more central ones should be bigger from that perspective, right? Exactly. So this is just a way of using this data to visualize it quickly, right? So if you wanted to do this now as in computation, basically, we can do it from Python client, but we can also do it from Cypher. So we can do a call GDS graph list. So this would show us the current in-memory graphs. Oops. Should we call now? But it doesn't tell us what we should use instead. So we have no GDS graphs right now. So what we can do is now basically do an we have our source station, our start station basically, right? Which is the start station. Then we have our cycle higher and then our end station. Target, cycle station. And then we could now just return this as a pattern, as a path basically, right? Return path limit 50. So this just shows us, like this is our start station and the other ones are all our end stations basically, right? So it's basically indirect. But what we want to have in our projection is actually return source, or what we want to do is with source, target. We want to see how often they have been used together, basically, right? So
okay, how many people basically took a bike from a station to get to another station?
No, how often exactly? How many people took a bike from this pair of stations, basically, right? So basically, how many people kind of traveled between the stations, right? And then we can say return source.name, target.name, and frequency, and we do limit 10 or something like that, right? So we see basically between these two stations, people, and we can also probably order it by, right? So order by frequency descending 10. So we saw between Hyde Park Corner and Hyde Park Corner, which kind of
it's probably they just took a tour around Hyde Park with their bicycle.
Oh, that's a good point, right? So they took it back, right? So
there.
interesting, Perhaps here the same, right? So what we want to do, we want to use this as our projected graph, right? So it's basically two nodes and then a weight as such, right? So what we can do now is we can actually do a call, return, use this as an aggregation function. We do GDS graph project, and then we have our graph name is basically bike hires. We have our source node, our target node, and configuration. I think it's relationship properties, if I'm not mistaken, is basically frequency. So, or is our, we can call it score or weight or something like that, right? So, it's frequency. So, and I think that's probably it, what we need to do, right? So we provide our target, our source. We could also pass in like labels for our relationship type of our nodes and so on. But because we only have one node label, we don't have to do this, right? So it's basically, so now after how much is this? 200 milliseconds. It took the 43,000 relationships that we computed basically, and 760 nodes. So it was pretty quick, right? So this is now our memory graph. So if I now do call gds.list, I should see our graph that we just, sorry, not GDS graph list. So this is our graph, and it gives us like a bit of distribution, the size of memory size, how many nodes and relationships are in there, and other stuff, right? So this was pretty quick. And now we can do basically call GDS PageRank stats, which just runs the algorithm on our graph called bike hires. And then it took 84 milliseconds to compute PageRank on this graph for all the nodes, right? So which is really nice.
Yeah.
Or we could do also clustering. So we could also do Louvain as well, and then it runs Louvain on this graph, right? So and then it takes like a second or whatever it took now. And now we could basically write this again back, and then we could say,
okay, yeah.
I think it's called mutate property. Mutate property is called Louvain. No, it's called write property, not mutate property. Sorry. So it runs the Louvain algorithm and writes it back into a property called Louvain on our cycle station.
On our nodes, right? Yeah, okay.
So it ran and wrote it back. So each of our cycle station nodes should now have a cluster Louvain ID. Right? Nice. So now we can basically say, okay, what are our biggest clusters basically as such, right? So we can say our cycle station and then return c.louvain in, comma, how many as count, order by count, descending limit 10. So we see basically we have one cluster that has 244, one with 209, 135, and so on, right? And then bunch that have no cluster because they're probably isolated nodes that were not connected in the import, right? So that were basically didn't have relationships going in and out as such. Right? But that's pretty nice and quick, right? So we can just run this as part of the database.
That's very nice, yeah.
Which is both good and bad, right? So because it runs in place to a certain size, it's actually quite easy, and you can project your memory graph and run it there. And of course, if you run it as part of your operational database, it also takes memory, and it also basically takes compute and so on. And especially if you have larger volumes of data, you want to basically outsource this, right? Mm-hmm. And so, as I mentioned, as we launched, when was it? Like
2 weeks ago. 3 weeks. Oh well.
3 weeks ago, separate serverless graph analytics, where you basically spin up a session of an arbitrary size. So you can say, I want to have an 100 gigabyte instance as compute, for instance, right? So, or a terabyte instance as compute. And then you can basically project your graph into that, and you can also load from other data sources, like from BigQuery or from Arrow, from some other place, from S3 or OneLake or GCS or so, from Parquet and so on. You load it into your graph analytics session, and then you run the compute, and then you can basically do that back as such, right? So, and the serverless graph compute is currently available only for business critical and virtual dedicated cloud instances that we used to call Aura Enterprise before. Mm-hmm. So I created one of those.
Okay.
And for those, it works. So I tried to use a Pro instance initially, but it said it's only available for these. Mm-hmm. So what we need to do is now to connect to this instance. Basically, do this similar thing here. Let's see if it's connecting. Okay. So it's currently data in there. Yeah. So it's basically I imported the same data before into this database.
I see. Okay.
just to show you how this works. And then you can use this either from Cypher or from Python, but I thought I'd just take the example notebook that they had as an example here, and let's try what this looks like for our database. Right. So I put all the required connection credentials and Aura API credentials into an end file here in my, I just uploaded this here so that we can use it. And then it's basically we import our dependencies, which are the graph data science library and .env for loading the end file, load the end file. And then we can basically create a GDS session by using the Aura API client ID and client secret and project ID. And if you do this, it's pretty quick. It takes you like a second or so. So we have now our sessions kind of API that we can use. And now we can create the actual session, right? So, and you can first estimate based on your node counts and relationship counts, kind of what size of session you need. I think we have only 200,000 relationships or something like that, right? So, and perhaps 10,000 nodes. So we can run this as an estimate. So it tells us what memory size we need. So it says 8 gig. It's probably like the lower limit, right? So I think it's probably not going further down. And then we connect and create a connection to our database here. And this DB connection is our database connection.
Yep.
And then we create a new session, which is this kind of virtual temporary compute instance, right? So, which is 8 gigs, and we use the name bike hires here as well, and it lives for 30 minutes. So after 30 minutes, it's automatically
okay, this goes automatically. Okay.
So if you know, for instance, that all your algorithm stuff only takes, 5 minutes, you can also just create it with 5-minute time to live, and then you run your pipeline. And if you forget about it, it will automatically be
that's good
removed.
To know.
So you don't pay for it, which is actually quite nice. So I thought I'd do 30 minutes because our session here, usually we do 30 minutes. So it does this. And then we should, when it's done, we should see it here in our list of sessions. Let's see. So this is not anymore running inside of our instance. It's a separate container to Sysl, which runs the graph compute.
Okay.
And where we can project data from the graph, but we can also load data from other sources as well into that session. Okay, so this takes, I think, a few seconds because it has to spin up a new compute infrastructure, right? So it took 33 seconds, and now we have our bike hires here as a new session ready to be used, right? And I think it even says when it does expire here. So it actually says it expires. Actually, it's a good question. Why it doesn't say expiry 2nd of June?
2nd of June. That does not. That does longer than 30 minutes.
Yeah. It should actually say 30 minutes, right? So okay.
But if you scroll right here, it says.
But it has TTL 30 minutes.
Here it says 0 days, but 30 minutes. So
okay. Let's ask
expiry date is something else.
colleagues why it says this. Okay, this one we can actually delete because this was just from the example. And now we can use GDS.run to test kind of what kind of data do we have in our database. It's 100,000 nodes, right? So and 200,000 relationships basically, right? So that's what we had already seen before, right?
Yep.
So all good. And now we can basically, similar to how we did it right now before, we can project our data again, right? We say this is our source node and target node properties. So imagine we have some numeric properties like vectors or floating point values or integer values that we want to use for some computation here. Then we can also put them in. Strings are currently not supported as part of the compute, but you can tie it back to the string of the name of the station later on if you need to. So we have basically our source, target, and count as we had before. And then it's also graph project, but remote, right? So it's basically doing it remotely. And then we just tell it, do it to the bike hires one, right? So and if we run this, it should hopefully be pretty quick. So you see you even have a progress counter, and it imported the nodes and relationships, same counts as we had before. And then we can basically run our PageRank.
Yeah. Okay.
So which takes 128 milliseconds to run, and then we see like what's the distribution here, and now we can basically look at the PageRank. So it's still in memory compute, right? So we can access this how often we want until it's end of life or how it's decommissioned.
Yeah.
So this looks nice, right? So and we, as you can see, we can actually pull information from the actual database, like the name that we didn't put into the projection. We can still pull this in. So it has this option to pull this together. And then if you only need this as a data frame, then we can just use the data frame here and use it in our own pipeline for whatever data science thing we're doing, right? And then the same we can use for graph neural networks, which is in FastRP is an GNN algorithm, and it would basically use our PageRank as feature property plus the topology. And then let's do this. I actually don't know how long it runs. Oh, that was also very quick. So it gives us like now the vector for FastRP basically for each of these, which takes both the topology into account as well as the PageRank into account. We see the PageRank as well. And then we can also say we want to write this back to our Aura instance now. And this writes this in 2 seconds back to our Aura instance. And we can also do this with Louvain again directly, where we compute and write back in one go, basically. So it does it all at once. And you see it's even faster with Louvain than it used to be in our extra when we ran it inside of the database, right? So they took a little bit longer back then, right? And now if you look at the data in our database, both the PageRank and the Louvain should be there. Why is it not there? That's a good question. Did we misspell it? Was it PageRank with an uppercase R? No, it's lowercase R. That's a good question. Where see the PageRank is not null. Perhaps it's the null ones that
yeah, okay, that's the same issue as
before. I thought it the nulls first, so that's why but now you see basically some of them like Waterloo stations is pretty central. And some of the other ones are also very central ones with high PageRank. And they are in different communities as well, right? So these are together because they are both on Liverpool Street, basically from the same cluster. And then the Waterloo ones are also, and the Bankside one is also on the same cluster.
Each other.
If you know London a little bit, then you know that this is going together, right? Exactly. And then at the end, we can clean up. We can either let the session expire or we can clean it out. And then it should be gone from our list again. And if you look in our database itself, if you refresh this, our cycle station should now also have all these attributes.
There's Louvain.
Sorry, database, like Louvain, PageRank, and everything else as well. Exactly. And I think that's what I wanted to show today.
Cool. Yeah. Yeah, that's very interesting and very easy. So for people, so we, if you want to just run a couple of algorithms, don't want to worry about, like you showed. I mean, you can export the results directly. If you don't want to write them back somewhere, you can do that. Or if you wanna do it later on, then I think that's a good way of working with that. I wanted to mention that our colleague Alison has written a lengthy blog post about all the various algorithms you can run on or with Neo4j Aura Analytics or Aura Graph Analytics, which I'm also sharing the link in chat. So that's maybe interesting as a additional, reading
reading exercise.
Yeah.
Awesome. Yeah. Very good. Cool. Oh yeah, that's a lot of detail.
Yeah, that's a lot of detail, but
cool.
different algorithms, different
social
way.
graph. Cool.
Yeah.
Super.
All right. Yeah, I think with that we are at the end. Thank you, Michael, for showing this today. I think I mentioned briefly already that this is the next episode we are We're going to talk about, Andreas will be talking about the AI Engineers World's Fair GraphRag track, which takes place next week. In Nodes is coming up. So on the 15th on June is the call for papers closing. So if you have any thoughts about submitting something through Nodes, if you have any interesting sessions you want to share, anything you find, anything you develop yourself, something graphy, something AI or not, up to you, visualization, graph analytics, like this, data science topics that are on the graph side of things, then please submit. You have what's it now? 2 more weeks, maybe 3, 15th. Well, it's exactly 3 weeks from today. So it's the Sunday in 3 weeks. So if you are thinking about it, do it rather than later, rather than sooner rather than later, and submit your sessions. We'd like to have you add notes, and obviously, if you want to know more, join the Graph Academy. Have 2 of the free online courses that are available there. Maybe do the certification if you are a certified developer, want to get that certified developer badge to show off to your friends or colleagues. You also get a free T-shirt if you do it. So maybe that's another incentive to check out that certification exercise. Check out Aura Free and our community pages with developer guides and resources. We are currently revamping that page, so you get lots of more content, lots of interesting things there. Michael recently wrote lots of content on GraphRag and MCP on the developer guide, so have a look at that and find that. And there's one question Veronique asks if the notebook you showed, is that publicly available or will you share that?
Yeah, so it's actually part of the docs. So if you go to, I mean, this one I can actually share because there's nothing in there that's kind of private or so. I basically just made a copy of the official one that's in the docs and adjusted it a little bit as such. But
we can also share the
let me just make this one.
Or you share it with me and I'll add it to the YouTube video description.
Yeah. So let me see. Can I make it everyone in the world?
Probably should link to the docs from.
Yeah, I'll send it to you so you can put it into the chat as well.
Yeah, if you have it, then.
So it will not have the credentials. So that's something that where you need to create your own instance.
Obviously,
because I uploaded those, right? So, but in your own session, you will have to upload your own credentials file.
Yeah.
Right. Cool. I got to go. I have another call, but
all right.
Spending time with you all, and I'm glad that it worked out and that all the demos worked. Always good to do
good that it worked today.
Hot coding.
Yeah.
Cool. See you all next time when we have our next session. That's looking forward to that. And then we also have an upcoming MCP webinar for those of you that have.
True. Yeah. Another point. 10th of June. Go to neo4j.com/events. You'll see it there. That's another cool, interesting session to look forward to. Yeah, thank you very much, Michael. Thank you for spending today, or rather,
take care, everyone.
Take care, everybody, and see you soon. Bye.